What is a closure, and why is it fundamental for asynchronous logic? A closure is a function together with a reference to its lexical environment, meaning it retains access to the variables that were in scope at the time the function was defined. What exactly exists is a function object, an internal hidden reference to an outer lexical environment, and variable bindings stored inside that environment record. The order is strict. When code is executed, an execution context is created. When a function is defined, the engine stores a reference to the current lexical environment inside the function internal slot. When the function is later invoked, it resolves variables through that preserved environment chain. Normally, when an execution context finishes, it is removed from the call stack. But if an inner function still references variables from that context, the lexical environment remains reachable in memory due to garbage collection rules. The causal chain is function defined, lexical environment captured, outer function finishes, inner function still holds reference, environment preserved, variables remain accessible. This is fundamental for asynchronous logic, because asynchronous callbacks run later in time after the original execution context has already finished. For example, when a timer or promise callback executes, it needs access to variables that existed when it was scheduled. Without closures, those variables would be lost after the outer function returned. Because closures preserve references, not copies, asynchronous callbacks observe the current state of those variables at execution time, which directly affects correctness of async flows. For a software engineer, this means closures enable state persistence across time boundaries created by the event loop. A closure is a function that retains access to its lexical environment, and it is fundamental for asynchronous logic because it keeps required state alive after the original execution context has finished.